user ID and password. Okay, we logged in. First, okay, we created a sample.txt file, okay, which is of size 250 MB. Okay, we created this file where in Edge node. We created this file in Edge node. Edge node and OS disk. In this disk, we created. Okay. After that, okay, what we have done, we executed a command. Okay, sdf put command. So while giving this command, you have clearly given that, okay, what is the replication factor you want and what is the block size you want. Okay, so okay, you have given the command here immediately. Okay, so when you press enter here, what will happen? Okay, in the backend FSL, writing algorithm will start. Writing algorithm will contact. Writing algorithm will understand. Okay, okay, with the help of Hadoop configuration files here, okay, writing algorithm will understand, okay, who is my name node, and it will contact that name node. Okay, so now name node will accept the request from FSL and okay and check, okay, whether it will check in the edit log first, okay, whether the file entry is same file is available in our metadata. If it is available, then okay, it will say file is already existing. If it is not available, what name node will do? So name node will update the metadata here. Okay. Why it is updating metadata here without writing the file? Any guess? Why it is updating? Okay, and why it is saying that okay, this in progress metadata status is like in progress? Huh? Tell me, guys. Any idea, guys? Okay, so here the reason is that okay, suppose that I'm writing a file. Okay, I'm writing sample1.txt, which is a big file, which will take 20 minutes. Okay, so 7 o'clock I started. Okay, so I started writing this file, but okay, 7:10 my friend also came and he checked okay, whether this file is available or not. 7:10, okay, this file is in progress. So if we check, okay, it is not available. So he will also start writing, right? Same file. He will think that okay, I told Venkata he did not. I guess he did not copy this file. Okay, let me copy this file. And he will also start copying the file. Okay, so that's the reason it will put the metadata entry before itself. Okay, but okay, the status okay is not committed. Okay, committed until the status is committed. Okay, you cannot say that okay, the the file copy command is successfully completed. So to see while loading the data, there is a chance that okay, your command may fail also due to some reasons. Okay, so in that scenario, it will roll back this transaction. Okay, so that's all different stories. But okay, however, okay, to avoid duplicate copy of the same file, okay, it is updating the metadata before itself. Okay, but when it is updating, will it update okay the block numbers at the starting itself? No. Okay, so it will make it like okay, so in progress, it will make it like this actually. Okay.
Yeah, Venkat, I can share my screen if you want now.
Sir,
if you are.
Is over. Okay, we'll connect at 9 o'clock.
Okay, no problem. Thank you, sir.
Okay. So this is the what I can say. This is the metadata. Okay, so now name node will give the confirmation to okay, writing algorithm. How can writing algorithm? Please go ahead and start writing your data. Okay, so now FSL will cut the data into pieces. Okay, what is the size of pieces it will use? You have clearly given the right. What is the size of piece you want?
Yes, sir. That is 128.
128 MB. Okay, so whatever the data I have, it will cut the data into 128 MB pieces. Okay, but I have 250 MB. Okay, it means first piece will come like 128 MB, second piece will come like 122 MB. Okay, 122 MB. Okay, so now okay, there are two pieces with two raw pieces with the FSL. Okay, now FSL will go and ask name node. Hey, name node. Okay, so I have two raw pieces. Can you tell me what is the name I should put for each piece and where should I put this one? Okay, so now name node is the one who will decide. Okay, so you write this first piece with the name 1825 and put it into bus data node S3N3 disk 1. Okay, and for the second piece you put this name and write into S3N5 and disk 1. Understood? Yes.
Here one question: why their first piece will be the H3N3, second piece will be H3N5. Wherever space will be there.
Wherever more space is available, sir. Okay, here okay, so Luckily, I have 9 hard disk from 3 different machines. Okay.
Okay.
All are having same free space, right?
Okay.
Okay. So now, okay, you understood this part till this?
Yeah, yeah.
So name node confirm this one. Okay, now, okay. So as per name node instructions, okay, writing algorithm will contact first data node 1, which is S3 and 3, and ask to write the data this piece into disk 1. Okay. Now here the service which is running in this machine, data node service which is running in the machine, will write the piece into first disk. Okay. In the same way, writing algorithm will contact third data node and ask to write the piece. Okay, in second piece in this disk. Okay. So now second piece will be written in this disk. Correct or not? Okay. So now as per H3 and 3, okay, what is this one, guys? See, as per this data node, or as per this hard disk, okay, what is this BLK?
It's block, sir.
One block. Okay, or one file. Yes or no?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay. So as per this, okay, suppose, okay, if I go and ask, okay, first disk, okay, in data node 1 first disk, okay, hey, how many blocks you have? What it will tell? It will tell I have one block.
One.
Okay? One block. Okay. So this will tell I have one block. Correct or not?
Yeah.
Okay. So now, okay, yesterday we opened the name node UI, right? We opened the name node UI, right? Okay. So now you see data nodes. Okay. Now, okay, are they representing, okay, what they are saying? Each data node. What each data node is saying? Like, see, did it report to name node or not? Here,
Yes, sir.
so there is another file which is called as a data node information file. So, which is nothing but this one, data node information report. Okay. Data node information report. Okay, what okay it will have? You can copy paste instead of wasting time here. Okay. So this is the data node information file. Instead, this one, okay, what I will have? Okay, what I will have? So node name. Okay, so here h3n3.hadoop.com. Okay, h3n4.hadoop.com, h3n5.hadoop.com. Okay. Then okay, what else? Okay, IP address. Okay, so last heartbeat. Okay, when it has started the last heartbeat. Okay, so 0 second. Okay, 1 second. Okay, so maximum heartbeat is within 3 seconds actually. Okay, last block report. Last block report. Okay. Okay. So then okay. So here okay. Okay. Total data, user data, free data. Okay. Free data percentage. Understand this? Huh? What is the total space here? Total data. Total. Okay. And number of blocks. Free data. Okay. Number of blocks. Okay. So this is a data node information report. Data node information report. Where this data node information will be?
Sorry, name node, sir.
No. Okay. So this is the report. Yes, name node will maintain. Okay. But okay, why I am putting in red color? Because okay, this is
Temporary memory, sir.
RAM. This is in RAM. Okay. So, but this is in
Hard disk.
hard disk. Name node hard disk. This is also in hard disk. Yes or no? This is also in hard disk. Will you agree with me? This is in hard disk. This is in RAM. Okay. Now, a number of blocks here. How many blocks we have? So immediately, so as soon as a new blocks written, okay, immediately. Hey, where are we writing this one? Correct way, na? Huh? Okay. So here, okay, we told that okay, each data node will be sending heartbeat to name node, right? Huh?
Yes, sir.
Each data node will be sending heartbeat to name node. Immediately when there is a, I'll put this in different color. Okay. So whenever there is a new block written here, immediately it will tell. Okay. So in my storage, I have one block. Okay. So S3N5 also will tell, right? I have one block. Right or not? Okay. So then,
Yes.
so what is the total space available here? 100 MB means, okay, 100 GB, right? So 100 GB means how much MB? 100 into 024. Okay, means okay. Total data available is 1024, this much MB. Okay. So in each disk, this is the space. Okay. What is the user data?
128 MB.
250.
So, okay, 3 and 3. How much? What is the size of this block? What is the size of first
128
block? 128 MB. Okay. The user space is 128 MB here. 128 MB. Okay. Okay. Here user space
122 MB.
128 MB. What is the free data? Here 0. Okay. What is the free data? Okay. This minus this. Correct or not? Okay. So now this is like okay, free data percentage. Okay. This is divided by this.
Sir, in total data, it will calculate only one disk memory.
Oh, okay, so all together, okay, how much? Okay, so total data was 3 disks, right? Okay, so easier example, sir. Sorry, you're right, sir. Okay, now you see what has happened here. So this is the data node information report. Okay, again, who will maintain this report? Again, name node only will maintain this report. Where it will maintain?
in RAM.
In memory. In memory. Okay, I'll remove this data writing this one. Okay, understand this? Understand or any questions? Okay. Suppose okay, guys, okay, so here tomorrow, if this report is lost, okay, again, okay, if I ask okay, each data node, okay, if name node asks, okay, hey, name node, can you send me your report once again? Will they send or not?
Yes, sir. It is every 3 seconds.
The data node will tell, okay, I have okay one block with me. My total storage is this much. Okay, user storage is 120 MB. Free storage is this one. Okay, so it means okay, the same report, even okay, if name node lost this report, okay, if name node asks data node, any data node, they will provide their details. Correct or not? Okay, that is the reason. Okay, so we are not storing this report in the hard disk. Clear? Or any questions?
Sir, I have one question here.
Yes, sir. Tell me. Sir, you there?
Yes, sir. Sir, can you hear me?
Now I can hear you.
Sir, FSL is writing algorithm, right? In the
Writing
same way,
algorithm.
do we have in the same way, do we have anything like reading algorithm?
Of course, yes, sir. I will explain that, sir. First, I'm explaining the writing algorithm.
Yeah, okay, sir.
Got it?
Yes, sir. Yes, I got it.
Okay. So, any questions here, guys? So next time onwards, okay, what? Okay, see, Now you ask me a question, sir. Okay, on what basis? Okay, name node has selected these nodes. Okay, so based on this percentage, understand? Based on whoever is having more free space, okay, it will. Okay, so it will. Okay, so here, instead of free data percentage, so free data percentage is not this one, right? 1 minus. So who is having, okay, so this is the free data percentage. Now tell me who is having more free space next time?
H3 and 4.
S3 and 4.
H3 and 4, sir.
100% free space. Understand? Okay. So like that, guys. Okay. So now,
Sir, one
Ah.
doubt, sir.
Ah.
Sir, at first, the free data percentage is 100% for all the 3 nodes.
yes, sir.
Or
Okay.
to for,
Before everything, okay, before you write any block, okay, everything is 100%.
then why it
Okay.
decides H3 and 3 and
Ah.
S3 and 5?
Yeah. Okay. So it will take a random decision now.
Sir, is it based on heartbeat, sir?
It can be, yes. Yes. But it is a random decision from name node, sir.
Yes, sir. Yes, I got it.
Okay. When there is a chance to select 2 nodes at the same time, okay, then okay, based on the heartbeat. Who sent the recent heartbeat? Okay, it will select that. Okay. So this is one file written. Okay. So now what we will do, let us run one more command. Let Alan run one more command. Okay. So let me go to here. Okay. The first file is done. Okay. So again, okay. So we checked, okay, in which node, okay, what is there. Yes or no? Okay.
Where we need to pass block number, yes?
Sorry, sir. Block number, sir. Yes.
Can you
yes.
execute, because I am getting some error for this? Just if you,
Yeah. Maybe. Sir. Okay, you did not configure well, sir. So when you're running clash command, you should run from S3 and 1 only. You cannot run from and S3 and 1 and SDP user only. You cannot use
Yes,
LN
sir.
here.
Yes, sir.
Got it?
Yeah, got it. So it is correct. Yeah. Okay. Yeah. Thank you.
Okay. Now again, okay. So again, what I'm doing, I'm taking the same file, one more copy, guys. So Alan, I'm doing the operation like Alan now. Okay. So Alan has copied the file here. Okay, it means okay. So I have sample2.txt also here. Sample2.txt. Okay, in this place, I have sample2.txt also, which is of same 250 MB size. Which is of same 250 MB size. Okay. So now, okay, try to understand here, guys. Try to understand what I'm doing. Okay. So home, Alan, sample2, okay, project BLR. Okay. What is the command I'm executing? What is the replication factor I'm giving here?
No, sir.
Huh?
2 replication factors.
So I'm clearly giving that okay, my replication factor equal to 2 here. Okay. In the previous example, I've taken my replication factor equal to 1.
Only.
Okay. But here I'm taking 2. And what is the block size I'm taking?
100 MB, sir.
100 MB. Okay. So can I select whatever I want? Of course. Yes, right. Okay. You put whatever number you want. Okay. Here, okay, you told 128 MB. So it cut the data into 128 MB pieces. Okay. Here, okay, you tell okay, your data into 100 MB pieces. Okay. Then okay. So we will see. Okay. Now, okay, when you write this command, what will happen? Press enter. Again, okay, in the background. Okay, in the background, JPS, if you see, command completed. Okay, that is the reason a capital is not there. But in the background, okay, so it is not there. So now, okay, we will see SDFS-DFS-LS project underscore DLR. Okay, is sample2.txt available here?
Yes, sir, it is.
Available. Okay. So now, okay, run this command, FSCK command. Now you check. Okay. FSCK sample2.txt. Okay. This is the command to check where my 5 blocks are available. Okay. Where my 5 blocks are available. Okay. So here, okay, I have sample2.txt. What is the total size? 250 MB. Okay. 250 MB. In that 250 MB. So how many blocks I got now? The first block. How much size? By 1024. by 1024. How much per block? Like if I have 250 MB data, if I cut it to 100 MB pieces, how many pieces I'll get?
3 pieces, sir.
Huh?
3 pieces, sir.
Can you tell me what is the piece size?
100,
100
150.
100 MB, 50 MB.
100, 150. Last one is 100, 150. Okay.
By default, it is 128. Yes, sir. Like if we will not give how
Okay,
much.
okay. We will see, sir. I'll talk about that also. Okay, now I'm executing the second command. Correct. This is the one I'm executing. Previously, I executed this command. Okay. Now, okay, I executed this command. Okay. So now, how many pieces this will be divided to? 100 MB pieces, right? So I will get 3 pieces now. Turn now. 100 MB, 100 MB. The last one is piece 3. How much?
50 MB, sir.
50 MB. Okay. So now, okay. Again, FSL will go and ask. Okay. So FSL, okay, will go and ask. Okay. So here, okay, I didn't put the block numbers there, right? Okay. And then it will put the block numbers 1825, 26. Okay. Committed. Okay. So this is the one. Okay. So now immediately, when this goes, FSL go and contact name node. Now name node will check in the metadata. Okay. Whether in the edit circuit is available or not. Sample to data. Is it available? No. Okay. Then it will check in FS image. Is it available? No. Okay. Then okay. So what name node tell? Okay. So name node will update the metadata here now. Okay. Will update the metadata here. Okay. So serial number 2. Okay. So file name is sample.txt. Okay. Location is same. Okay. And today we are doing and block size equal to 100 MB. Replication equal to 2. Okay. And it is in progress. Yes or no?
Yes, sir. Sir, here I have one question, sir. This permission 644, what is that, sir?
Sir, 644 means okay. You see here, what is the permission of this file?
Read write.
644 means 6 means read, R means 4, W means 2, 6, 4, 4.
Okay, sir. Okay, sir.
Got it?
Yes, sir.
Okay. So now, if you see this one, okay. If you see this one, okay. So 100 MB block size, replication factor 2. Okay. Now at this moment, okay, does name node knows the block numbers and all? No, right? So now,
No,
okay, name node will tell, okay, FSL cut your data into pieces. Now, FSL will cut the. Okay, now it is asking name node, hey, name node, can you give me the name for each piece? Okay, the name of first piece here. 1827. Name of the first piece is 1827.
yeah,
Second piece,
228.
second piece, third piece. Total 3 pieces it has got. Okay, the size of first piece is 100 MB. Size of second piece is 100 MB. Size of third piece is 50 MB. Okay, now where these pieces are stored. Okay, if you want to check that one, you need to check in the class node. Go to class node means okay. Here you check. Now, what are the pieces we have here?
27282.
1827. Where is 1827? 1827 is in H3N3 disk 2. Yes or no?
Yes, sir.
H3N3 disk 2. Okay. Then 1827. So now, so here the same 1827 is in S3N4 disk 1. Why it is right in 2 places, sir?
Because we are giving a replication factor 2.
Exactly, sir. Okay. Because okay, we have given replication factor as 2. Okay. So that is the reason. Okay, each piece it is writing in 2 places. Got it?
Sir,
And
in
then
case,
1828.
sir, in case any block got corrupted, what is the process to retrieve it? Like manually, we need to copy it, or it will
No.
automatically be
I will tell you, sir. That also.
okay.
Okay. I'll tell you. Okay. So now the second piece is 128. 128 is where? It is in 183 machine and which disk? Disk. Okay. And where is this 1828 copy? One more copy. Okay.
One more time machine.
H3 N6 N6 and which disk it is?
Disk 2.
And okay, again okay. So where is the next one? Okay, here piece 3. Piece 3 is in 1829. Okay, is in 183 means disk 1. Okay, this is the one disk 1. Okay, and 29 it is in disk 2. Understood, sir? So I'm not suggested, okay, you put this name for first piece and write into first data node and second data node. First data node disk 2. So it means, okay, so 1827 will be written in first data node disk 2. Okay, and okay, second data node disk 1. Understand, guys?
Sir,
Okay.
how name node will understand? First one is first block, second one is second 100 MB is a second one.
Based on this, sir, based on this. Based on this table.
No,
Okay.
sir. What I'm doubt is
Ah,
FSL cutting into 3 pieces, what about configuration 100 MB is like that?
ah,
The block size. The
ah,
third piece is 50.
ah,
The third piece is 50 MB, na?
ah.
But name node, how it will understand this? Maybe third one also first file, that means first block one like that.
Okay. So for each block, first it will select this table, sir. Okay. Who is having more free space? Okay. So N4 is having more free space. That is the reason it selected this one. Okay. Out of these two, who is having more free space?
That is for storing purpose, na, sir.
Ah,
That free space available that can be stored that node only.
ah,
But what I am doubt is there are 3 pieces are available. FSL is cutting.
ah.
The third piece may be the first file, maybe like that. His name node, maybe.
Why third piece is the first one? It will go in order, right?
Okay.
It will go in order, right? Okay. So suppose, okay, let us take one thing, sir. Okay. So have a movie, sir. Okay, you cut into 3 pieces. Okay. Piece 1, okay, piece 2, piece 3. Okay. What name you will give for first piece, sir? Huh? Maybe you will give part 1. Yes or no? Part 2, part 3. Yes or no? Okay, will you give part 3 to this one? Okay, part 2 to this one, part 1 here. Okay, reading will be problem, right? Okay, by looking at the names, you may think that okay, this may be the part 1, but actually this is piece 2. Correct or not?
Yes, sir. Yes, sir.
Okay, so it will give a unique number, but okay, if you have 3 blocks, okay, that unique number again, okay, increment by 1. Got it? Okay, so again, okay, there will be a naming algorithm, sir. Okay, block naming algorithm. Okay, using that algorithm only, name node is deciding these names. BLK underscore some number and all. Okay, so how it is deciding that number? It's purely based on the naming algorithm. Got it? Okay. So now first piece is written here. Where the second piece is writing 1828. 1828 is in F3 N3 disk 3. This is the place. Okay. Then next piece F3 N6 disk 2. Okay. Where it is this one? Okay. Again, okay. Block 3. F3 N3 disk 1. And where is okay? So this one S3 N4 disk 2. No, this is 29, right? Understood, sir? It has written like this successfully. Okay. Now tell me, okay. So immediately, once it is written successfully, okay. So what, okay. Algorithm will say, okay, fine, please update your metadata. Okay. Immediately it will update the metadata like this actually. Okay. So for this file, okay. So 27, 28, 29. Okay, and the status is Okay. Understood, sir? Understood?
Yes, sir.
Okay. Hey, now without having this table, okay, how will you, okay, so will you understand that, okay, which block is related to which file? Is it possible?
No, sir.
No, right? Okay. So this is a reference table actually. But this metadata, without metadata, you cannot find where is your actual data. Okay. So now once this is done, it is committed immediately. What, okay, each data node will tell, okay, this data node will send a report saying that, okay, hey, name node total, I have 4 blocks with me. Yes or no? So
Yes, sir.
second data node will tell, like, I have 2 blocks with me. Third data node will tell, like, I have 2 blocks with me.
So,
Okay? Now, what is the user's phase here? So this is okay, 128 MB, 100 MB, 100 MB. Okay, 100 MB, 100 MB. How much this one now? 120 MB, 328 MB plus this is 50 MB. Okay, 328 plus, okay, 50, 378 MB. Okay, so total space used is 378 MB. 378 MB. Okay, so this one 27, 29. Okay, 150 MB. Okay, and this one extra 100 MB came. Okay, so 222 MB it is showing. Okay, so immediately it is updated or not?
yes, sir. It is updating.
Okay, now if you see name node report, okay, it will you can see this one 224 blocks. Okay, so what is the total utilization here? Okay, understand?
Yes, sir.
Got it right? It's updated immediately or not?
Yes, sir. It's updating.
Immediately, as and when there is a new block, it will update immediately. Okay, so in the same way, this report also modified accordingly. Clear?
Yes,
Clear?
sir.
Okay. Now I hope, okay, you are understanding, okay, what is reading algorithm. Sorry, what is writing algorithm? Okay. Now we will do one thing. Okay, we'll write one more file. Let Alan write one more file. Let Alan write one more file. Okay. Okay. Then, okay, copy sample3.txt, like, okay, sample3. Okay. Now I have sample3.txt. Okay. So it means where is sample3.txt? Where is sample3.txt? It is in here, in this place.
Ln sum directory.
Again 250 MB. Okay. Again 250 MB. Again 250 MB.
Sir, in real time also, always we have to define it for every file. We have to define it those
No, I'll tell
replication
you, sir.
factor.
I'll tell you, sir. Okay. If you can give me some time, okay, everything will be clear, sir, for you. Okay. Okay. I will tell you when you should ask the questions. Okay. So now, okay. Now, guys, okay, try to understand what this guy is doing. What this guy is doing, okay. He's trying to copy a file with replication factor.
4 and block size 300 MB.
Block size equal to 300 MB. Yes or no?
Yes, sir.
Okay, he is trying to copy. He has sample3.txt. He want to copy this file into this SDFS. But what he is giving? He's saying my replication factor equal to 4. Okay. And what is the size of the block?
300 MB.
So Alan will press the command here. Okay, let's say he will press the command here. Okay. So now you see JPS. Okay, you have FS shell. Once command is successfully completed, FS shell is closed. Okay. So now you go back here. Okay. Now tell me, guys, so how many pieces you will get? How many pieces you will get? Huh?
5 pieces.
Okay. What is the size of, okay, see, what is the size of my file?
250 MB, sir.
One
So
previous
one
one,
piece only you will get, sir. Only one piece.
So, but I am telling my block size is 300 MB. Okay, how many pieces I'll get now?
One piece only.
One piece. Okay, one piece of size 250 MB.
250.
Okay, yes or no? Okay. So immediate class, okay, so now it will check in the metadata again. It will check in the edit log whether sample3 is available or it is not available. Okay, now it has written sample3.txt. Okay, here Okay, so file size equal to 250 MB. Okay, but block size equal to 300 MB. Yes or no? Okay, replication equal to 4. Okay, so this is in progress. Now, okay, so now name node will tell, okay, fine, cut your data into pieces. Okay, now if I cut my 250 MB data into 300 MB pieces, I'll get only one piece. Okay, so now, okay, we will see the details for this piece. First of all, okay, we'll check whether
Venkat,
it's
here
copy.
they will cut two pieces, right? 300 MB, right? One is 250, another 50 MB is there, right?
Sir, okay. Sir, try to understand this one. I have one file, sir. This is the file. Huh? Okay, this is the file, which is of 250 MB, sir. Okay, which is of 250 MB. Okay. Now I'm asking like, okay, cut into 120 MB pieces. What you will do? Cut into 120 MB pieces. What you will do? First, in this file, first you will take up to 128 MB. Okay, you have taken. Okay, so this is 128 MB. Yes or no? Yes or no, sir?
Yes, Venkat.
120 MB. Okay. After taking this much, okay, what is left out here? What is left
122.
out here? Huh?
122.
122 is left out. Correct or not?
Yes.
This left out okay, will come here. This is the full file. Okay. But I'm cutting into 128 MB piece. Okay. If I cut into 120 MB piece, okay, what is the piece left out? Okay. Now this is the piece left out. Yes or no? This will come like, okay, altogether, this is like 122 MB. Yes or no? Yes or no, sir? This is
Yes,
the full
Venkat.
file.
Yeah.
Correct or not? Okay.
Correct.
So now if I cut, okay. If I cut, okay, how it is coming? It is coming like two pieces like this. Correct or not?
Yes, Venkat.
Now, okay, I have the same file, 250 MB file. I'm asking you to cut into, okay, 100 MB pieces. 250, you divide by 100. 100, first piece, second piece 100. And third
50.
piece, how much is left out?
50.
So here what it will do, first I'll take 100 MB. Till this, okay, I'll take this piece. I'll put it like 100 MB. This is the first piece. Okay, then same file, second piece. This is also 100 MB. Okay, third piece. Okay, so you will get it like. Yes or no?
Yes, Venkat.
Now I have the same file. Okay, I'm asking you to cut into 300 MB pieces, sir. Understand? So I'm asking you to cut into this much big piece. But okay, do you have this much big piece? The total data itself is only till this, right?
Correct, Venkat.
Huh?
Yeah.
సార్ ఇప్పుడు చూడండి మీ దగ్గర ఉంది 250 ఓకేనా అవునా నేనేమంటున్నాను నేను మీ దగ్గర ఉంది 1/2 kg సార్ నేను కేజీ ప్యాకెట్లు కట్టమంటున్నాను నేను ఓకే ఏం చేస్తారు మీరు మీ దగ్గర ఉంది 1/2 kg ఉంది మీ దగ్గర 1/2 kg ఏదో ఐటెం ఉంది ఓకే బట్ నేనేమంటున్నా అంటే కేజీ ప్యాకెట్లు కట్టండి అంటున్నాను నేను ఏం చేస్తారు
హాఫ్ కేజీ అడుగుతాం సార్
లేదని చెప్పిన ఎక్స్ట్రా యాడ్ చేస్తారా మీరు? అర్థమైంది సార్?
Okay.
ఇప్పుడు
Understood.
ఎక్కడ
Yeah.
ఛాన్స్ ఉందంటే అంతవరకు 1 kg కడతాను నేను. లాస్ట్ లో కొంచెం మిగిలింది అనుకోండి, దాన్ని ఏమంటారు, అయ్యా బాబు లాస్ట్ లో ఎంత మిగిలి ఉంది, దీన్ని కూడా 100 దాంట్లో కడతాను, బట్ మీకు లాస్ట్ లో 1/2 kg వచ్చింది అంటారు. అర్థమైంది కదా?
Understood, sir.
Okay. Okay. So here calculate only one piece of size 300 and 250 MB. Okay. Now let's see what is the name. Okay, your name node has given for this one. First of all, we will see whether the file is copied properly or not. Yes, I have sample3.txt available here. Okay. So now let us see the status of this file. Okay. Now if you see, okay, how many pieces it got? It got only one piece. What is the piece name?
1830.
The piece name is 1830. Okay. What is the size of this piece?
250 MB.
250 MB. MB. Okay. And where it is available? Now I told to put in 4 places, right?
4 places. Yes,
4
sir.
places. Okay.
4 places.
So now we will see 1830 where it is available. Where it is available, sir? One copy is available in 184 machine disk 3. 184 machine disk 3. Okay. One copy is available in 184 machine disk 3. One copy is available in 183 machine disk 2. Here I have disk 2. Understand, sir? Huh? Understand, sir? How many copies I have? Only
we have only 3 copies, sir, but replication factor is
183 machine. Okay. In which node?
disk 2.
Huh? Disk?
Disk 3, sir.
Disk 3. Disk 3. Okay. No, 183 machine disk 2. 184 machine disk 3. Okay.
Sir, here, but the replication factor is 4 only, sir. Only 3 copies. Replication factor is 4, no?
But okay, how many times it has written?
3 times.
So it has written 1 copy in 183, 184, 185. Okay, where is the 4th copy?
I think
check that it's a
Redundancy.
duplication of.
Where is the 4th copy? So you remember one point here.
Under replication, this will be under replicated.
Okay, so okay, when I was explaining this slide, okay, block is never replicated on the same node. Understood? Okay. It means, okay, so now in all 3 nodes I have one copy. Okay.
Yes, sir.
If I want to put 4th copy, I don't have 4th copy chance for 4th copy. Okay, but still what it is saying here, when I check this one, it is saying that, okay, see here, target replica, but there is a warning it is throwing, guys. For others, okay, it did not throw any warning, but okay, here it is throwing a warning. Target replica is 4, but only I found 3 copies. Okay, it is a under replicated one. Understood? So here under replicated block 1. What do you mean of under replicated block? It is not there as, okay, Hadoop is not maintaining whatever the copies you requested. You asked a replication 4, but okay, you asked for replication 4, but okay, it is maintaining only 3 copies. Why maintaining only 3 copies? Because it has only 3 data nodes.
Yes, yes, I got it, sir.
You got it right.
If we add one more data block,
if you add one more data node, automatically the fourth copy will be created by name node. Understood? automatically fourth copy will be created by name node. Understand?
Can you explain me one more time on that?
Okay.
I'm not clear on that.
Okay. Sir, now, okay, as per Alan is telling that, okay, hey, please maintain 4 copies of this file. 4 copies of this file into SDFS. Okay. So now, how many data nodes we have?
3 data nodes.
3 data nodes. Okay. I cannot give, okay, one person two same copies. 1 data node, 2 same copies. Okay. So I have 3 data nodes. Okay. 1 copy given here, 2nd copy here, 3rd copy here. So I don't have 4th data node to give the 4th copy. But the rule is that okay, I cannot give 2 copies for the same
1%.
same data node.
Data node.
Yeah. Okay. That is the reason it is saying that okay, it is a under replicated.
Sir, that means in each and every data node, we can store multiple pieces of different types, but not same pieces.
Not same. See here, okay. See, I have 1828 here, sir. Correct?
Yes, sir.
I cannot put 1828 here, sir. I cannot have same 1828 okay, in the same machine, different disks.
Yes, sir. Yes, sir. Got it.
You got it right?
Yes, sir.
You cannot have same 1828 okay, 2nd copy in this machine in any of the other hard disk also.
Yeah, there is no space for data duplication. Yes, sir.
Okay. So here, okay, suppose okay, now I want to maintain a 1828 2 copies. Let's say okay, you put it here. Suddenly, if this node is down, okay, so both copies will go right, will go off right.
Yes, sir. Yes, sir.
And what is the point of maintaining replication factor? Multiple copies.
Yes, sir.
Okay, so that's the reason. Okay, so Hadoop will not allow same copy to put in same node twice. It may be different disk, but okay, no blocks. Okay, block will be copied twice in the same node.
Now understand.
Understood, right?
Yeah.
Okay. So this is the problem. So now, see, even if I give a replication factor for Hadoop has taken, but okay, what it is showing, wherever it is possible, it is writing. Whatever number of copies it is, it has the possibility, it has written. Okay. But okay, wherever it doesn't have a possibility, it is throwing warning, saying that okay, hey, you are supposed to have 4 copies, okay, but okay, you have only 3 copies. Target replica is 4, but found only 3 copies. Understood?
Yes, sir.
Okay, so it is throwing a warning here. Okay, till this okay, you are clear. If I'm not wrong.
Sir, if it is any limitation for replication, is there any limitation for replication?
No, sir. No limitation. Okay.
For
now
example,
this is
if 1000 data nodes are available, I want to
Uh-huh.
take the replication is 1000, then it will create name node.
you put
1000.
sir, in each node one copy it will create.
No impact on name node and no impact on.
Nothing.
Thank you.
Sir, okay. On name node, okay, is it maintaining okay? Is it maintaining okay? Only with number, right? Here.
Yes, sir.
Yes, sir. Only information.
Only information it is maintaining. Then where is the pain for name node?
Sir, one question here.
But okay, why do you want to have 1000 copies, sir? First of all, tell me.
No, sir. No. Is it possible or not? That's why I'm
Yes, it is possible, sir. Sir, okay. You tell anything to Hadoop, okay. It is possible. Answer is yes.
Okay.
Anything you tell in technical way. It is possible with Hadoop. Yes, sir. Tell me. Somebody else is asking.
Yes, sir. One question, sir. You are running all these command on edge node, right?
Yes,
so
sir.
If we run these command on name node or data node, will it work? Just my question.
Of course, sir. Okay. See, when I say cluster, okay, you can fire command from anywhere.
Okay, sir. So
Understand?
the same thing.
Okay.
Yeah.
But okay, the problem here is that okay, see, if I am allowing Alan to log into this machine and okay, allowing him to run the commands, okay. So he can see this, right? Suppose okay, I will do one thing. Okay, I will log into S3N1 as Alan. Okay, I log in as Alan, right? Okay. Let's say Alan see that okay, what is the MNT disk 1? Can I see? has permission denied. Okay,
Yes,
so
sir.
but fine.
You
Okay,
don't have permission, yes, sir. But
don't have permission. But okay, what in case? Okay,
but as a HDP user, sir, but as HDP user, we can do it, right?
yes,
In case of admin,
yes.
if the admin want to run any command, then he can
Yes,
run
yes.
from anywhere,
Okay,
right?
but okay, running the commands on name node is safe. So by
No,
mistake,
not
okay, while deleting something, okay, you deleted FS image, complete FS image. Gone case, right? Okay. Okay. While running a command, okay, you deleted okay, all these 3 disks. Then okay, all the blocks will go off. Yes or no?
Yes, sir. Correct.
If I have replication, that's fine. Otherwise, gone case. Yes or no? Okay.
Yes.
So this is about okay writing processor. Okay. Last one. Okay. What I will do? Okay. CP sample4.txt. CP sample4.txt. No, here. Edge node. Now I have copied this as a sample4.txt. The size of this file is again 250 MB. Okay. Now what I will tell, my command is like this, sir. Okay. Okay. Now okay. Now tell me, in this command, am I telling any replication factor?
No, sir.
Am I telling any block size?
No, sir.
All right. I'm not telling anything. Okay. So here I'm giving blindly. I'm giving blindly that okay, hey, copy my file. This is the command I'm giving. This is the command. Okay. So when you give, okay, when you run any command, okay, without passing these parameters, then what it will take. So first of all, okay, let us see whether it will work or not. JPS in the backend FSL is there. Is it working? Command is working. Yes, completed also. Okay. Now the question that okay, did you tell any replication factor, or did you tell any block size?
No, sir. If we are not telling, it will take a default size.
Okay. If you are not telling anything, okay. So now, first of all, we will see whether it is copied or not. Whether sample 4 is there or not. Yes, sample 4 is copied successfully. Okay. Now, okay. Let us see the properties for sample 4. For sample 4, what is the file size? 250 MB. What is the block size?
128
You
MB.
tell, okay. Huh?
128.
128 MB.
128.
Okay. This is divided by 1024 divided by 1024. What is the block size here? 128 MB. Okay. What is the replication factor?
3, sir.
Okay. Now the question is that okay. Okay. You didn't give these 2 properties. From where it has taken these properties?
Sorry, sir. I didn't get
Default
you.
properties.
Did you pass?
Default size.
Earlier, okay, you passed what is the for sample1.txt, you passed what is the replication factor and what is the block size, correct?
Yes, sir. Yes, sir.
For sample 2 also you passed those replication and block size. For
Yes, sir.
sample 3 also you passed, but sample 4 you didn't pass anything.
Yes, sir.
But still it has taken okay 128 MB and replication factor 3. Okay, now the question is that from where it has taken.
Sir, that is the default size, no, sir.
From configuration files.
Default size.
Okay, so default means okay, the default numbers also should be there somewhere, right?
Yes, sir. Okay. Those are in configuration files, as I said. Yeah.
So if you see here, cat user local Hadoop etc Hadoop SDFS cipher site XML. So here, okay, we have put, okay, if users don't give any replication factor, go with the default of 3. If users don't give any block size,
block size.
go with this block size. Understand?
Yes, sir. Got it, sir.
Okay. So if you don't give anything, then it will go as per the configuration file. Understand?
Yes, sir.
So here, okay, why it chose, okay, this one based on the configuration file, because you have not passed any value. If you pass your value, see, if you remember, okay, if you pass your value, it is taking your value. If you don't pass your value, it is taking
This one configuration values.
configuration properties. Okay. So for this one, again, okay, it has divided into how many pieces? Okay, we will see. So divided into how many pieces? It is divided into 2 pieces. Okay. This is block 1. This is the first piece 1. 3.1 and 3.2. Piece 1 of 128 MB and piece 2 of 122 MB. Right? Yes or no?
Yes.
Piece 1 is 31, piece 2 is 32. Okay. What is the replication factor here?
3.
Replication factor 3. Or not? Okay.
Yes, sir.
Okay, we will see in which hard disk it is exactly copied. Okay. We want to, what is the block numbers we want?
3, 1, and 3.
Okay. Otherwise, okay, so what we can do? We can extract only sort egrep this is better. Okay. Now, okay. Okay. So now, where is the 31 first copy?
In 183 discount, sir.
183, 31, right? Okay. So 31 is in
Disk 3.
okay. So 31, disk 3. Disk 3. Okay, 31. Where 32 is there? Otherwise, okay, where? Okay. We have 31 and 32. Okay. 31. Okay. 183, disk 3. Okay. 180, disk 1. Yes or no?
Yes.
Then where else it is there? 185, disk 1. Understood? 185, disk 1. Okay. Then okay, we have what is the second piece here? What is the second piece name?
1832, sir. Please.
1832. Okay. Now let us search for 1832. 1832 is in 183 disk 1. Disk 1. Okay, 183 one copy here. Where is the second copy? 184 disk 2. Disk 2. Then where is the third copy? This also disk 2. Yes or no, sir? Huh? Yes or no?
Yes, sir.
It will update the metadata here saying that. Okay. 4 sample 4.txt. Okay. Okay. So block size equal to 128 MB. Replication equal to 3. Okay. 31 comma 32. Yes or no? And status is committed. Correct or not? Okay. Now it will tell the number of blocks also. The number of blocks also changed right now. So now, okay, so 755. Okay, so in the first one, 755. These are the blocks. Okay. User date also, user space also more here. Understood or any question? So here, if you come and see in this data node, you will see only the block space. Understand?
Yes, sir.
Each disk, okay, in the data node will have only blocks. Okay, each disk in the data node will have only blocks. Each disk in the data node will have only blocks. Understand? Huh?
Yes, sir.
Understand, guys? Okay. So, but okay, which block is related to which file? Where that information is available? At this moment, it is available in the edit log.
Sir, in edit, edits disk, data is not available, sir. I mean, which?
In edit, disk information is not there, right?
Yes, sir.
Okay. So here there is another report, right? Okay, remember, okay, what is the fourth file name we will maintain, guys? Block report.
Yes, sir. Black report.
Block report. Okay, again, okay, that will be maintained in the RAM. Correct or not?
Yes, sir. Yes, sir. Got it. Black report will maintain the node information.
Exactly. So here, so block number, then okay, so replication, okay, then node details, okay, nodes and status, nodes and status. Okay, so this is the one. Okay, so now what I will do, I'll push this one a little bit down. Okay, so now, okay, what is this block? What name node will do now? Okay, whatever the block numbers we have in this column, it will take all those block numbers and it will put it here. Understood, sir?
Yes, sir. Yes, sir.
186. Okay. Then 1826, 27, 28, 29, 29, 30, 3132, 30, 3132. Okay. Now, what is the replication factor for 25? 1. What is the replication factor for 26? 1. Replication factor for 27, 28, 29?
2, sir.
2, 2, 2. Okay. What is the replication factor for 30?
4, sir.
4. Okay. What is the replication factor for 31, 32 blocks?
3.
3, sir.
So this is the table. This is the table. Okay. Now, okay. Now, okay. So what? Okay. Each data node will tell. Each data node will send a report to.
Name node.
I would say that, okay, hey, I have these blocks with me. Okay. How to? Okay. So how to generate a block report here? Okay. This is the command. Okay. It will use. Okay. So what 183 is telling? What 183 is telling? I have these blocks with me. 1825 with me. Okay. So 1825 one copy is with me. Okay. So 183 means. Okay. Let me copy this output somewhere to a notepad. Okay. So it is telling 1825 with me. Okay. 183 is nothing but
Data node 1.
DN1. Okay. So this is nothing but DN2. Okay. This is DN2. This is nothing but DN3. Okay. So what DN1 is telling that I have 1825 with me. Immediately it will update. Okay. 1825 DN1. Okay, 1826 is with. Okay, so now data node 3 will tell. Okay. DN3 will tell. Okay, where is 1827? 1827, one copy here and one copy here. Okay, data node 1, data node 2. Okay, 1828, data node 1, data node 3. DN1, DN3. Okay, 1829, 1, data node 1, 2. Data node 1, 2. Okay, and 1830 in all three places. DN1, DN2, DN3. Okay, understand?
Yes, sir.
Okay, so where is okay? 1831 in all three places. Okay, where is 1832 in all three places? Okay, this is what it is maintaining now. Okay, now it will compare. Okay. Now, what is the status here? When I say status, what do you mean of status here? Okay, status. Okay, so here now, how many copies I'm supposed to have this block? What is the replication for this block?
One copy, sir.
One copy. So data node 1 is telling that I have one copy. It means okay. So it is a
active.
Okay. Now this is having one copy and data node 3 is telling I have one copy. Okay, this status is okay. Okay. And this is supposed to have two copies and two data nodes are saying that okay, I have one copy. Correct?
Yes, sir.
Status is okay. Okay. This also two copies, data nodes. Status is okay. Two copies, two data nodes. Status is okay. Four copies, three data nodes.
Under replication.
Understand? So four copies, but three data nodes under replication. Okay, three copies, three data nodes. That is okay. Three copies, three data nodes. That is okay. Understood?
Sir, one question.
Yes,
in case we add one more data node, what will happen to under replication? Will it automatically?
Okay, suppose if you are data node 4, automatically name node will ask this one. Okay, ask any one of the existing data node to copy 1830 block to newly added data node. Then okay, that newly added data node will send a report to name and send okay, hey, I have block 4 also with me. Okay, this block with me. So immediately name node will update this one. Okay, so now 4 replication, 4 data nodes. Status is okay now. It is the responsibility of name node to make sure the status is okay for everywhere.
Venkat, one question. Here replication is 4. In case data nodes is 5 means that time it will come to over replication.
Why? Why over replication?
No, my question is replication is 5.
Okay. So 5 data nodes are say, okay, I'll tell you that scenario also.
Okay.
But you understood this under replication concept? Huh?
Yeah.
You understood under replication concept, guys?
Yes, Venkat.
So let us take this scenario, sir. Let us take this scenario. Okay. Suddenly, data node 3 is down. What will happen, sir? Okay. So here, what I will do, I will put it like this, sir. Okay, so DN1, DN3, I will put it like this. DN2. The nodes also I am maintaining here. So block data node, okay, both. So here DN1, DN1. So this is DN3, this is DN3. Okay. DN3, this is DN1, DN2, DN3, DN1, DN2, so DN1, DN2, DN3. DL3. Okay. Okay, sir. You see here. Okay. Suppose now, okay, this is the situation. Okay. Suppose suddenly, okay, if data node 3 is down, sir, what will happen? Data node 3 itself is down. Okay, 1 second, okay. Not data node 3. Okay, in data node 3, okay, third disk is gone. What will happen? You understood? Third disk is gone in data node 3. Okay, data node 3 is running, but third disk is gone. Then okay, what okay, data node 3 will tell. Data node 3 will tell like a name node, hey name node. Okay. Earlier I told that okay, I have 1830 block. Okay, but okay, the disk is not working with me. So remove my name for 1830. Understand?
Yes, sir.
So what name node will do? Okay, name node will come check this report and check this report. Okay. Okay. Check this report. Okay. And wherever okay, so disk 3 is there. Okay, so okay. From disk 3, whatever the blocks we have 1830. Okay, so it will remove 1830. Data node 3 will be removed here. Understood? So now this is anyway it is under application, but still it is under application. Okay. Think that okay, empty disk 1 is gone. What will happen? So under disk 1, okay, what we have? 1826.
1826 and 1831.
This is there. Okay. Then 1831 also there. 1831. Okay. Both will be deleted. Now you see, as soon as the name is deleted here, okay, they became under application. Correct or not?
Yes, sir.
Okay. So now the question here is that okay. So what will happen?
So
okay. So
now Venkat, disk 2 is active, but disk 1 and 3 inactive, correct?
No. In this scenario, no. Okay. Disk 1 only down.
Okay. Then got it. Yeah.
Okay. Now disk 1, disk 3 fine. Okay. Disk 2 down. What will happen? 1828.
1828, 1832.
1828. Okay.
32.
These two will become under application.
So in case disk 1 is down, what will happen to 1826? I think data will lose.
I'll explain that. Okay, but you understood now you understood the concept, right? Huh?
Yes,
if
sir.
the disk is down, okay, whatever the blocks available in the disk, okay, those will be marked as under application. Yes or no? 1828, okay, under replication. Okay. So 1832 under replication. Yes or no?
Yes,
Okay.
sir.
Suppose, okay, so now you fix the issue and this disk is back, then what will happen?
Then status will be okay, sir.
Yeah, so DN3 here and okay, DN3 here also. Status is okay for that. Got it? Okay, but what in case, okay, if entire node is down? Everything will be removed, yes or no?
Yes, sir.
Entire node is down means, okay, whatever the blocks it has, everything will go down. Correct?
Yes.
Correct or not? Okay. So now in this scenario, okay, suppose, okay, now, okay, this node is down. Okay. Now name node will check what are the under replicated blocks we have. Okay. So this is under replicated block. Okay. But okay, so you try to understand here. How many copies I'm supposed to have here? Only one copy. Okay. The node which has that one copy lost. Can I replicate now? 1826. I cannot replicate because, okay, no more copies, right? In data node 2, data node 1.
Yes, sir.
Okay. So I cannot do anything until, okay, this one is back. Okay. That is the reason keeping any data with replication factor 1 is danger. Yes or no?
Yes, sir.
If that node is gone, okay, your entire data, all copies are gone. Yes or no?
Yes, sir.
Okay. So now, okay, you take this second under replication. Okay. So now it is saying that 1828 in data node 1. Okay. So 1828 in data node 1. Okay. So now it is under replicated block. Okay. Data node 3 is down. Okay. Can I ask? Okay. Can I? Okay. Now. Okay. Can name node ask? Okay. Can name node ask? Okay, data node 1 to copy this 1828 to data node 2. That's right. Huh? So in this scenario, think that, okay, 1828 is copied from here to here, data node 2. Okay. Now, okay, immediately once block is copied, now this will say that, okay, I have 1828 with me. Okay. Now the status has become okay. Right or not?
Yes, sir.
Status has become okay. Okay. So now, okay, this one, can it do anything?
No,
Already
sir.
these two are having, okay, so it cannot do anything for this one. Okay. Can we do anything for this one? Already one copy already here. So I cannot do anything here. For this one also, I cannot do anything here. Correct?
Yes, sir.
Okay. Now suddenly, okay, data node 3 is back, sir. What will happen? Now data node 3 is back. Okay. Now data node 3 will tell, okay, I have 1826 with me. Okay. 1826 with me. Okay. Then replication has become automatically okay. Okay. I have 183 and with 31 with me. Okay. DN3. Okay. For what? Okay. I have 1828 with me. 1828. Okay. But okay, here, okay, you see, guys, what has happened?
Over application.
Over replication. Okay, because, okay, I'm supposed to have 2 copies, but I have 3 copies. Okay.
Yes, sir.
I have 1832. Okay. Yes. Okay. Okay, it has become. I have 1830. Okay. Okay. But still, this is under replication only because, okay, we don't have 4th copy. Okay. So now, but here, okay, there is something called over replication. Why
Yes,
over
sir.
replication?
More than replication factor, it is having 3 copies.
Yeah. Why over replication happened in this scenario? Why over replication happened in this scenario?
Because the data node was down now, sir.
So data node was down for some time. So what name node has done? Name node has replicated some of the blocks here. Okay.
Yes,
Now
sir.
what name node will do? Now name node may delete this block 1828. Okay. Now
Yes,
it will say I don't have 1828. Now name node will update this report. Now okay. Sir, all your questions are solved now. Now okay. It's time to ask questions. Okay.
Okay.
Whatever questions I told, okay, wait. Okay, now you ask me.
Sir, my one question is there any command to
So,
check
sir,
the
while
overall health
data
of?
node 3 was down, it has copied the file to the different node, right? And made the status to okay.
Blocks.
Sorry, the block to the different node, and the status was okay, right? So even the status was okay when the data node 3 was back up. Name node is somehow getting all the blocks back to its original node.
Yes.
Where is it going to get that information? Because
Sir,
the status already is okay, right? Here.
No. Okay. No. See, even the status is okay also. What is the standard rule of name data node, guys? Whenever it started, whenever it start name node, so what it will do first, it will go and register with the name node, and in that, so then it will start sending heartbeat, right? In the second heartbeat, it will send all the block report. If you remember this page, so see, send heartbeat to name node for every 3 seconds and updates its presence and any changes in the storage level. Any changes means these are the ones.
Okay, so it's going to come once it is back up, it's going to compare it with the previous.
Immediately it will tell, hey, name node, I am back. So I have these blocks with me. Please update my numbers. Immediately name node will update. When name node update these numbers, now this has become over replication. Got it?
Got it. Yeah.
So, sir, whenever a new block joined here, whenever a block removed from here, understand? Or whenever data node is started, immediately it will pass this information to name node.
Sir, one question. Sir, is there any command to check the overall health of the cluster? Like what are the replications are happening?
Exactly, sir. So this is there is a command. So what is the command? So FSCK. See here, FSCK is the file system check command. FSCK means like a file system check command. If you run it for overall root, now what it is saying? So here it is telling that so we have one. It is checking all the files, guys. You see, it is checking each and every file, checking sample 1, sample 2, sample 3, sample 4. And it is checking inside this also. Inside this credit card, Coral, Gold, Platinum, Silver, every file in each and every directory it is checking. And finally, it is giving me reports saying that so total files are 4. All together I have 8 blocks. At least one copy is available, 8. There is one under replicated block. Understand? So here also it is showing. See, it is showing target replicas are 4, but found 3. Yes or no? So this is the command to check health check of entire file system. But I'll be explaining what is this command, what are the different options we have in the next upcoming classes. Got it?
Yeah,
Yes.
one more question, sir. I think you already answered this one. Sorry if you already answered it.
No problem.
So let's say if the user have submitted a job which is going to put some fields into the HDFS file system and the replication factor is 5, but we only have the 4 data nodes in active state. So as is it going to
put only 4 copies and 50 copy it will show like warning.
Yeah, but is there any specific formula that as long as the data, as long as the it has completed one loading up the blocks into all the blocks into one set of blocks into all the data nodes, let's say it is going to get the completion to the user, isn't it? Or does it follow any kind of formula that just
sir. Okay, so you are talking about in details of writing algorithm. I may explain that in the upcoming classes. So here, what are the in detail steps on writing algorithm? So here, file write. Yes, your question, I understood your question. But I will answer your you will understand the answer for this your question in this. Got it?
Sure. Yeah. Sorry, thanks. Yeah.
Okay, any other questions, guys?
Sir, I have one question that we are writing the algorithm. Writing algorithm will name node will tells that which node is, which data node is free space.
Yes, sir.
Okay.
Yes, sir.
And how come it is going to select which disk is free?
Sir, okay. See, end of the day, here, we come to know that which data node is free. Yes or no?
Yes, sir. Yes, sir.
So now, it is telling that so now name node is telling that name node is telling that put this block into data node S3 and N3 and N1. So now, okay, block will be given to DN1. Okay, now here data node service is running, right? The data node service will it is responsibility of this data node service to put in all the nodes. Understand? See,
Yes.
which node is free, that will be decided by name node. Which disk is free, that will be decided by data node.
Yeah, okay, sir. Thank you.
Got it?
Yeah, got it.
So FSL will give.
Responsible.
Yeah, FSL will give block to data node 1. So it is the responsibility of data node 1 to see which disk is having more free space under it, and in that it will put.
It's a responsibility of data node. Which
Data
disk is
node.
free. Okay,
Yes.
thank you.
Any other questions?
Sir, what is the maximum block size that we can pass?
You can pass any number, sir. You can pass any number.
And
But okay. So here, okay. So can I pass, okay, 5 TB?
No, sir, no.
5 TB block size, single block size. Then if I have 10 TB, well, I'll get only 2 blocks. Correct or not?
Below 100 GB, we need to put.
Okay, so even okay, GB is also bad, sir. Okay, max to max, okay, 512 MB, a block size is good number.
Is there any performance issue? And
of course, yes, right. Of course, yes, right. Sir, okay, suppose, okay, your data is in 100. Okay, you have 100 data nodes, sir. You have 100 data nodes in your cluster. Okay. Now you have a file. Okay, if you cut into 100 MB pieces, so you have 100 pieces. Okay, if you cut into 120 MB pieces, you will get how many pieces? 100 pieces. Yes or no? Okay.
Yes, sir.
If you cut into 256 MB pieces, how many pieces you will get? Your overall
50,
file, if you cut
50,
into 120
50.
MB pieces, you are getting 100 pieces. 256 MB
50,
pieces?
50.
50.
50. Okay. So 512 MB?
25.
You get only 25 pieces. Yes or no? Okay. Now, do you think, okay, which one is better? Which one is better?
128.
You have 100
128.
data nodes. Okay.
128 MB, sir.
100
okay.
pieces are fine, I believe.
Exact 100 pieces are, because okay, each piece will go and sit in one data node. Got it? Got it,
Yes,
sir?
sir.
Each
Yes, sir.
piece will go and sit. Okay. So it means the writing will be faster. Okay, in this scenario. So in case of writing, in writing algorithm, writing and reading. In writing process also, 100 data nodes will be part of this one. Sir, no? Because you have 100 pieces, 100 data nodes. One piece will go to one data node. Or not?
Yes, sir.
Now you have 100 data nodes. Okay, 50 pieces. How many data nodes will work?
50.
Only 50 data nodes will work. Sir, no? It means, okay, so it means you have 100 people. You are not giving work to 100 people. You are selecting 50 people and you are giving more work to 50 people. Yes or no?
Yes, sir.
Yes or no, sir?
Yes, yes, sir.
Yes, sir.
Okay, which one is better now? So
100
now
people.
here, okay, so 25 pieces means only 25 data nodes will work. Or no? Each data node, okay, if each data node take one piece, okay, I have only 25 pieces, right? Only 25 data nodes will write my pieces. Correct or not?
Yes, sir.
Okay, it means only you are making 25 data nodes to work. Now, okay, remaining 75 data nodes sitting ideally, not doing anything.
Yes, sir. And it will take more time also.
More time also. You are giving more load to these 25 data nodes. Correct or not?
One question here, Venkat. See, we have 3 disks. So it will be like and three data nodes. So my question is like 3 disks means 3 writers in the disk also, yes? So will it be better to put, let us suppose I have a big file. If I will give 3 partitions, like three blocks, means that would be better or 9 would be better in
What
the
is the
same
3 or
scenario?
9? What is the 3 or 9?
If I can divide the same file into 3 blocks or 9 blocks,
Okay,
there
how
is an
many?
option. Yeah. So
How many disks you have?
I have 9 disks, but
Then 9 blocks is better,
three
right?
data nodes.
Then 9 blocks is better, right?
9 blocks is better because
Better.
okay. So we mean to say that an individual disk also can contribute to the
Of
performance.
course, yes.
Okay, sir. Got
Yeah.
it. Yeah. Thank you.
Sir, and again, to avoid this confusion, okay, what Hadoop is doing, Hadoop is giving a standard, guys, okay. You take 128 MB default, okay. Don't think, okay, how many blocks you have, how many data nodes you have, how many disks you have. Don't think, okay. Go with a good number of 128 MB for any file.
Sir, while writing, you are placing number of replica, right, sir? So if you don't put anything, then it will by default will take, three, right?
Yes.
And block size also, if you won't put anything, then it will take 128.
128 MB. Whatever is there in the configuration, it will take that number.
Okay, sir.
Understand, sir?
128 is a default for block size for 3x, right?
2x. 2x.
2x.
If it is 3x, 256 MB.
So if it is reduced for the block size is 100 MB, is there any performance issue, sir? If you reduce?
Sir, okay, see. Okay, if more blocks we have, more metadata you will have. Yes or no?
Yes, sir.
Sir, I can give a block size as 2 MB also. Okay, then 250 MB means how many blocks I will get? 125 blocks I will get, correct or not? Okay. So the more block numbers, the more metadata, more the size of bigger size of block report. Yes or no?
Yes, sir.
And again, okay, so here, okay, putting 2 blocks and putting 125 blocks, even the edit log size also will grow or not?
Yes, sir.
Okay. So less block size means more metadata. Okay. Big block size means less metadata. Correct or not? So we need to play a game in such a way that, okay, say your performance should not be worried. Sir, okay, here, okay, see, I'll tell you, okay, less block size. Okay, advantage, disadvantage, advantage, okay, disadvantage.
So we can choose medium, I think. So.
Okay, advantage is that, okay, less block size means, okay, so more blocks, more data nodes, okay, more data nodes. More data nodes, okay, more parallelism, okay, and okay, more performance, okay, but okay, the disadvantage is that, okay,
More metadata.
So more metadata means burden on name node. Yes or no? At the end of the day, name node has to maintain all these things in one copy in RAM, right?
Yes.
Then more burden, right?
Correct.
Yes, sir.
So with the big block size. Yes, sir? Small block size. Big block size means how many blocks you'll get. Disadvantage is that, okay, less blocks. Okay. Advantage is that, okay, less metadata. Okay. Less burden on. This is advantage. Okay. Disadvantage. Okay.
Time taking.
Few blocks. Okay. Few data nodes. Guys, please be on mute.
Yeah, less parallelism.
Less parallelism. Okay. Less performance. So you need to go in a medium way. Not with the Ganesh, sir. Understood? Okay, so you need to go in a moderate way. Okay. You need performance as well as you need less burden. So in between is better.
Sir, we were installed Hadoop 3x now, sir. So that the block size.
Yeah, block size 256 MB, but I put in the configuration file I put 128 MB. And I put.
Yeah, okay.
Okay.
We were changed, right?
We changed it. We customized it.
Yeah.
Normally, if you are using Hadoop 1.x, okay, block size is 64 MB, sir. If you're using Hadoop 2.x,
Yes, 2 into 64.
Yeah, okay. 3.x, 256 MB. Okay. But okay, can't I put it in 1x itself? Can't I put 256 MB here?
No, sir. No.
The numbers they are giving. Okay, but you have an option to customize in the NEX.
Okay. That means in 1x also we can able to
put
block size to
256 MB.
Okay, sir.
Sir, okay, some people what they will do, they'll put a block size as 200 MB, 100 MB, 200 MB, 300 MB. Like that they'll put. Is there any problem?
Okay, no.
No problem. Okay, it's up to them because okay, Hadoop is giving you an option to customize. Got it?
Yeah, got it, sir.
Is there any rule that okay, every cluster should have same block size?
You said that is a default.
Depend to company. Hadoop is giving that okay, hey, this is my default number. Okay, so if you like my default numbers, you go with this one. Otherwise, you don't like my default numbers. Okay, you put whatever number you want. Understand?
Usually in real time,
Usually real time people go with the default ones. But okay, I've seen some companies like okay, where they have the block size of okay, for 2x they have block size of 200 MB. Understood? Okay. So I hope all the doubts got cleared. Okay. So now let us try to understand the read process case. What will happen when you try to read the file? When you see all this time, what happened? It is a writing algorithm. Any questions?
Sir, question. In real time, do we have only one edge node and all the developers use the
No. See, it is based on number of developers, sir. How many people will log into one edge node? Okay, capacity of the data edge node. In our cluster, we have 21 edge nodes, sir. Because okay, we have more and more developers. So if all developers log into the single edge node, the edge node will go down.
Yeah.
Load will be more on the edge node. So it's up to you how many edge nodes you want to.
Okay.
Clear? Or any questions?
Clear, sir.
Okay. Very good, sir. Very good. Okay.
If we need to add one edge node to our cluster, simply we can just push the
create a node and okay, install Hadoop and okay, just copy the configuration file, the set of configuration files from here to here. That's it.
Okay.
Nothing. You don't need to
Instead, we can do one thing. Yes, means if we will copy name node directly, but if means we are not going to run anything. Yes, like kind of.
Yes, sir.
If we have a okay, got it. Sure. Thank you, sir.
Now let's talk about.
Sir, if we want to customize this, accordingly we need to change this change in
customization. Customization can be done in 2 ways, sir. Okay. So here, customization can be done in 2 ways. One way is that okay, put in your command line itself. No? So I did that here. Whatever properties I want, whatever size I want, I'm putting in the command line itself. One is okay, put your properties in the command in your command itself. This is one way. Okay. So and okay, it will work only for you.
Yes, sir.
For your file. Okay. Understand? Okay.
Yes, sir. Yes.
So other way of customization is okay. So put the in XML files. Okay. So if you put an XML file, okay, this will work. All users.
Sir, this XML is configuration file.
Configuration file. XML is nothing but a configuration file.
Yes, sir. Got it. Got it. Thank you.
If you put in the configuration file, it will be for all people.
All users. Yes, sir.
Yes, for all users. If you put in the command line, that will work only for your command. Got it?
Okay, sir. Got it, sir.
Yeah. Any other questions? Any other questions, guys? Okay. So if no questions, okay, we'll go for the reading part. Okay. Now, if you want to read a file, what will happen again? Okay. So again, ln. Okay. So now SDFS DFS -ls project BLR Bangalore. Okay. Now he is seeing the data here. Okay. Now sample1.txt. Okay. Okay. These are the files. Now I want to read sample1.txt. Okay. What command I will type? SDFS DFS cat. This file name. Okay. Before running anything, I will GPS. Okay. Now when I run this command, what it is saying? Is it printing or not? You see JPS? Again, okay. While reading also you have FSL, correct or not? Now once the printing is completed, FSL is closed. It means okay. Even okay, the reading algorithm name also FSL. Understood, sir?
Yes, sir. Got it, sir.
Reading algorithm. Okay. Again, okay. So here, len. Well, the command he is typing, the command he typed is this one. Okay. This is the command. Okay. When you run the command, what will happen? Immediately, FSL in the backend, okay, FSL will start. Okay. FSL will take this command and give it to name node.
Name node.
Understand? Give it to name node. Now what name node will do?
It will check in first image.
Data. First, okay. Will it check in the FS image or edit log? First preference is edit log. Whether sample1.txt is available or not.
Yes,
it's there.
It is asking project Bangalore sample1.txt. Is it there or not?
Yes, sir, it is there.
Yes, it is there. Okay. Now, okay, it will go here and now it will take the block numbers here. What are the block numbers for sample1.txt?
1825 and 286.
1826. Correct or not? Okay.
Yes, sir.
So now it will take these two block numbers, then it will come to block report.
Block report.
Okay. Now, where is 1825 and 1826? These are the ones.
Node 1 and node 3.
Okay. It will copy these details. Okay. Node will copy these details and hand it over to
reading algorithm.
Reading algorithm. So now, reading algorithm has the details. Yes or no?
Yes, sir.
Has the details like, okay. So what is the, okay, how many blocks it has, okay, and where those blocks are available. Okay. Now what reading algorithm will do now? Now reading algorithm will see this report. Okay. So my file, whatever the file, okay, my boss is trying to read sample1.txt, that is divided into two pieces, 1825 and 1826. So 1825 is in data with the data node 1, 1826 is with data node 3. So what it will do? Now reading algorithm will ask data node 1, hey, give me 1825 from your storage. Okay. So it will ask, okay, data node 3, give me 1826 from your storage. Now it is the responsibility of data node to see in which disk it is 1825 is available. Okay. So 1825 is available in the disk 1 itself, correct? So it will read 1825 data and give it to reading algorithm. Okay. In the same way, 1826, okay, so data node 3 will read 1826 block and give it to reading algorithm. Now, okay, reading algorithm has got both the blocks. Now, as per the order, it will merge into single piece. When it merges into single piece, what is the size of single piece? 250 MB. 250 MB. This is 128 MB. This is 122 MB. Total together?
250 MB, sir.
250 MB. Okay. So now it will merge these two pieces into one piece and start printing on the screen like this. Understand?
Yes, sir.
Are any questions now?
Sir, here I have one question, sir.
Yes, sir.
Sir, as you know, in metadata, this disk information will not be available. So these data nodes will maintain this disk details in their own RAM.
No, sir. Why?
Because in metadata we don't have a disk information. Like we
Sir,
have only black. Black.
Sir, wait. Okay. See, all these four files are metadata files only, na?
Yes, sir. Yes, sir.
Okay. See, here I am putting the block numbers, and okay, these block numbers are available in which nodes. That information I'm maintaining here.
Yes, sir.
We are already, name node is already maintaining this report now. Then okay, how can you say that okay, name node is not maintaining this report? Name node is clearly maintaining that okay, 1825 is with data node 1, 1826 is with data node 3. Clearly maintaining all this information, right?
Yes,
why
sir.
data node should maintain once again? Name node is already maintaining it, right?
Yes, sir. Name node is maintaining block details and the data node details. Yes, sir.
Yes. Okay, so based on this, okay, it will pass this information to whom? Reading algorithm.
Reading
algorithm will go on and get the data here.
Merging also, reading algorithm will only do.
Yes. Reading algorithm only. See here. Splitting also done by reading algorithm. Correct?
Yes, sir. Yes.
Merging is done by reading algorithm. Yes. Yes. Okay. And okay, now let us take, okay, let's say you are writing, okay, you are reading sample2.txt, sir. Okay, you can process same, right? Okay, it will launch reading algorithm. Reading algorithm will contact name node. Now name node will check in the metadata for sample2.txt. It found okay 3 blocks 1827 2829. Okay, so now 1827, this is the metadata, correct?
Yes, sir. Yes, sir.
Name node will pass this metadata to reading algorithm, correct?
Yes, sir.
Now there is a thing. Okay, now reading algorithm understood that okay, my file, entire sample2.txt file is divided to 3 pieces. That is fine. Okay, but first piece is with how many data nodes?
Two data nodes.
Okay. Now the question is that okay, will it ask both the data nodes or it will ask one data node?
Both.
Whichever
free, that
So if it is asking for both, okay, I will get duplicate copy. Yes or no?
Yes, sir.
So now out of these two, whom I should ask? Whom okay, data node will okay.
Which is
FSL will ask.
Whoever is free.
So when FSL understood that okay, there is a block which is with more than one data node. Now what FSL will do? FSL will ping data node 1 and data node 2 parallelly. Okay. Now, okay, so it means okay, see here, okay, so it will ping like this actually. Okay. So ping. Okay. S3 N 3. Not S3, S3 and 3. Okay. Ping S3 N 4. Okay. Now you see who is taking more time, guys. So okay, you take the first line itself. Okay. So this is replying in 0.322 seconds. This is replying in 0.264 seconds. Who is fast?
S3 and 4.
S3 and 4 is fast because it is responding immediately. So it will ask S3 and 4 now.
The name node is checking for the two data.
Not name nodes are officially reading algorithm is checking, sir. Who has to read this data? Sir, okay. Name node is a person who will help you in the metadata. That's it. Name node will tell, hey, your data pieces are available in so and so nodes. You go and take it. That's it. Understand? So name node is giving this information to reading algorithm.
So reading algorithm will check
it is the headache of reading algorithm to get the required blocks from these data nodes. Okay. But okay, here there is a challenge for reading algorithm. Okay. So in the name node given metadata, okay, given metadata, 1827 is available through 2 data nodes, but I want only 1 copy.
Yes.
So in this scenario, okay, from which data node I should take?
Which one is fast, it will take.
So who will ping? FSL will ping. Okay, data node 1, data node 2. Whoever replies first, okay, it will take that one. Okay. Now for block 2, it is evolved with whom? 2 people again. Okay. So S3, N3, S3, N5. S3, N3, S3, N5. Okay. Out of this, who is faster?
Yeah. So reading algorithm will check both the nodes. It will
S3
take.
and 3
is faster.
S3 and 3 is faster. So it will ask, okay. So it will ask, okay, give me this one. So out of these two, data node 2 is faster, correct?
Yes, sir.
For this block, okay, data node 1 is faster. Correct or not? Okay. Now for this block, 1829, data node 1, 2. Okay. Data node 1, data node 2. Which is faster?
Data node 2 is faster.
Venkat, just a query. So while reading, this is the it will give work based on the ping. But while writing, it need to write both the places. Yes, like the same thing.
Okay. Yes, it has to write in both the places, right? Okay, you write here first, you write here second. Okay, no problem, right?
Yes, yes. But in that case, it will not ping. Yes.
It will not ping. That cases it will not ping.
It will just instruct.
Yes, it will give based on the name node instruction. First, it will go to data node 1, write it here. Then go to data node 2, write it here, and come back.
Got it.
That time no ping.
Internally, again, these 128 blocks were divided into 4 KB blocks and storing
it. Of course, yes.
So that information should also be stored right in block report.
That information will be stored in the disk fat, local fat.
Okay.
Understand,
Venkat, if it gave work to data node 2 and suddenly something went wrong with data node 2.
Suppose, okay, now, okay, while reading suddenly data node 2 is down. Okay. So now, okay, I want to read 1827, sir. Okay. So I want to read means, okay, FSL want to read 1827. It pinged these two. Data node 2 replied fast. Okay. Now, okay, FSL asked data node 2, hey, can you read my block and give it to me? Okay. Now it is reading. During reading process, okay, suddenly data node 2 is down. Then, okay, it will get a bad signal to FSL. Now, and when FSL get a bad signal, immediately FSL has only other option is DN1. It will go and ask DN1. It will ignore DN2 now. Understand, sir?
Yes, sir.
Got it.
It will ignore.
So let's say the user is submitting the job from the submitting the select or that get from one of the edge node.
Reading job or writing job, sir? Reading job or writing job?
Reading job. So the ping is going to happen from that specific edge node itself, right? Because the FSL
of course, yes, wherever FSL is running, okay, from that node only it will happen.
Okay, so even if that happens on the data node, from that specific data node, it has to make the ping to itself or to other data nodes.
Of course,
just
yes,
in case.
Yes.
Okay, thanks.
But okay, think that okay, in real time you will not do any command, you will not execute any of these commands from these nodes, because these nodes are having very important. This is having metadata, this is having actual data blocks. Okay, so by mistake, if you give access to these nodes to developers, okay, access to developers to these nodes, they may delete any of these things. Actually, they may feel, hey, what is this BLK? Do you think, okay, so you are admin, okay, now you understood this one, okay, you go and ask, okay, if you have any known Hadoop admin, go and ask, okay, so what will be there in the data node? How many people will answer? Just see. Or you ask any developer. Developer doesn't know all these things, right? They know only these commands, sir. Understood?
So yeah, so just a quick thing over there, Venkat. So from the edge node is also a part of the cluster, right? It's not part of the HDFS, but it's part of the cluster. So as long, let's say if the user or somehow he got access to the root or some super user on the edge node, or let's say sudo. So let's say sudo to his group, and that group is in the HDFS. He can still be able to access that specific.
He can still access, yeah, that's right, sir. Sir, tomorrow developer is doing something else, we are giving him access, right?
Yeah.
Whose mistake it is? Admin
It's
mistake.
it's an admin mistake. I have to make sure he
Yes,
only gets access to what
You
he's
need
able
to
to
make
get.
sure, okay, the developer should get access to only his files, not others' files.
Yeah.
If developer is deleting some others' files, means okay, yeah. Hey, I've seen some scenarios, guys. Okay, so one of the candidate, okay, in our team, okay, so my manager scolded. I mean, somehow, okay, there was a miscommunication between, okay, the manager and employee, okay, and okay, so finally he, I mean, okay, he was forced to resign. Okay, what this guy has done, okay, he has written one script, okay, and left. Okay, the script has run after 3 days of his, okay, his last working day. Okay, he scheduled that script. Understand? Okay, so the script, okay, he has access and he was able to delete it actually. So he scheduled his script, okay, to run after 3 days. Okay, now whose mistake it is, tell me? And it deleted, okay, it damaged our cluster. Somehow we had backup and we restored. We took 2 days time and we restored. But okay, whose mistake it is now? Tell me.
Admin.
Admin mistake. Why admin mistake? If any employee left immediately, we should disable his ID. Yes or no?
Yes, sir.
Yes.
Why okay you didn't disable the ID for 3 days?
Yeah, that is
Yeah,
admin mistake.
nowadays companies are doing it even before before
Yes, sir.
there
Yes, sir. Yes. Okay.
the
So
exit
suppose
process.
if today is my last working day, they will disable all my IDs yesterday evening itself. That's what, okay, in the current company, my they are following. They'll clearly send a communication saying that, yeah, saying that, okay, so tomorrow is your last working day. Please close everything by today, end of the day. Understood? Tomorrow morning, you will have access to only the HR portals, no other things, no work related access you will have. Understood, guys? Okay. So I guess, okay, you had, okay, you got an idea like, okay, how, okay, the reading, writing, all those things, how distributed file system is working. Yes or no?
Yes, sir.
Yes, sir.
Okay. Now, okay.
Venkat,
Where
just
and
one
all,
query. So admins will see, we are executing this admin queries in S3N1. So in real time also, we will execute in name node like as an admin. Admin will execute all the admin commands in name node or where?
Yes, you can execute in name node or you can execute outside also, sir. Not a problem. When I say cluster, okay, you can execute any command anywhere. But end of the day, see, suppose, okay, I execute my command from here, but okay. So suppose, okay, if I execute my command here, FSL will start, okay, but FSL will contact name node. Yes or no? Even though I execute command here, the actual execution is starting from here only, right?
Yes.
Let's say I gave you access to data node. You execute a command here. So FSL will start in the data node, okay? And again, FSL will contact name node only. So that is the reason, okay, you remember, I told that, okay, name node is the first point of contact for here.
Yes, sir. Yes, sir.
What is name node? First point of contact for all CFS operations. You do anything from anywhere, okay? Without name node notice, okay, nothing will happen in the cluster.
Got it, sir. Thank you.
So in that case, okay, what you can do? So you can run your command from anywhere. End of the day, command execution will start from name node.
Hey, Venkat, because someone already asked this question. Sorry if it's outside the topic. What is the manager node? I'm actually doing everything from the manager node itself, not data node or name node.
Sir, okay, so okay, good, sir. Edge node, okay, so here, okay, did I explain, okay, what is edge node here? What is edge node, sir? In some people, okay, we call it application node, okay, gateway node, manager node, connecting node, client node, okay. So different companies, they'll give different names, sir. Understand? So you're doing something means, okay, that's also edge node.
Okay.
Got it.
Thank you.
So any other question, guys? Okay.
Sir, in case of the data nodes, second is these disks is there, no, sir. SDB, SDC, STD. We are going to load the data in this disk. Okay, where we are going to store the local metadata in this disk.
Each disk will have local metadata, na? Each disk.
Okay. Each disk will
have local fat, right?
Okay, right.
Sir, okay, see, this is a hard disk. Okay. So now, okay, data node is asking hard disk, okay, you write this block for me. Yes or no?
Yes,
What
sir.
is the rule of hard disk? Whatever data it is writing, it should cut into 4 KB pieces and store it here. Yes or no?
Yeah.
And it will update the metadata in the same hard disk fat file allocation, local fat.
Is there any information stored in the RAM, sir, in this data node?
No.
Nothing, sir.
No.
But sir, block report is stored in RAM, yes?
Of course, yes. That's what I put it in red color, right?
That is
Okay, yes,
name
sir.
node RAM.
Name node RAM. So all these are in name node RAM. So NN HDD, name node HDD. Okay. So edits also name node hard disk. Okay. So block report also name node RAM. Okay. And data and information also name node RAM. Okay. Clear, sir?
Sir, one doubt, sir. Sir, while performing reading and writing algorithm, sir, till now there is no use of FS image and secondary name node.
Yes, sir. Till now. Okay. That is the next class I'll explain, sir. So, sir, what will happen? Okay, if I keep on storing my metadata like this, one fine day edits will become big file, right?
Yes.
Yes, sir.
Okay. So here, okay, when I start secondary name node, what will happen? Okay, every 1 hour, whatever metadata we have here, it will shift to FS image. Understood? That I will start. Today time is over, right? Okay, tomorrow, I mean, in the next class, okay, in the next class, I will start the secondary name node, and I will show you how this metadata will be shifted to FS image. I'll show you tomorrow.
Okay. Venkat, one just a query. Actually, while installing Hadoop, we did this link listing, like to the folder where we extracted this Hadoop. We link listed means we created a shortcut link.
Yes, sir. Yes, sir.
So instead of that, means why we are creating, if we will go with the main folder itself, is there any problem?
Sir, okay, see, okay, now let me tell you here, okay?
Yeah, sorry, I am asking a little.
No, sir, no, sir, okay. If you don't ask, I will feel bad, sir, seriously. Okay, so I want to see my configuration file, sir, okay? LL user local, okay? So here, this is the main software directory, and okay, I pointed to Hadoop, yes or no?
Yes, sir, yes.
Now I want to open configuration file, okay? So what I will do, vi user local Hadoop -3.3.0, okay? Then okay, etc Hadoop, okay, and SDFS site XML.
Yes.
One is better, okay? Or okay, just the Hadoop is better.
Hadoop looks better, yes.
Every time I only type this one, right?
Okay, sir, got it.
Today I have 3.30. Tomorrow, okay, my company asked me to upgrade to 3.3.1. Then I will have 3.3.0, 3.3.1 also. Both softwares will be there.
Yes.
Which one you will find?
Better to go with Hadoop only, yes.
With Hadoop only.
Got it, sir. Yeah, thank you.
Okay. So, any other questions, sir?
No.
Tomorrow classes are there, sir.
Sir, okay, we had one missing class, right? Okay, shall we do it tomorrow? I know you will say no. I know that. Okay. But okay, I will say yes. Tomorrow morning, okay, we have class. Okay.
No problem, sir. Yeah. Same time, sir. Same time, same
Tomorrow
link.
morning, same 6:40. Okay, same time 6:40. Okay. If there's any change, okay, I will update in the WhatsApp. Okay.
Okay, sir.
But I think that tomorrow morning we have class. Okay.
Yeah. Okay, sir.
Sir, 6:50.
6:50. Yes. And one more thing, guys. Okay, so okay, there are almost 25 plus people who have not paid the balance fees. Okay. Sir, okay, to be frank, okay, asking every day, okay, or sending a message every day. I don't know how you feel, okay, but I feel very sad to send the message because, okay, see, we are learning, we should do our responsibility, okay. Okay, so please pay. If not today, you have to pay tomorrow. Yes or no? Okay, please make the payment, balance
Yes,
payment.
Venkat.
Okay, and you can send me the screenshot. Okay, otherwise, okay. So if you have anybody has any issues, okay, so please talk to me. Okay, talk to me. Okay, so otherwise, okay, please make the balance payment. And if not, okay, I'm very strict, guys. I'm punctual and I'm strict also in few things. Okay, when I say class 6:50, you will see me at 6:50, whatever is the situation. Okay, so in the same way, okay, so from Monday, I will not allow people if who have not paid the fees. Seriously. Okay, thank you so much. And okay, think that we have class tomorrow.
Sir, quick question, sir, if you don't mind.